Hello, my friends. My name is Priyanshu, and you are watching Statistics My Passion. In this session, we will learn about the various measures of central tendencies, median, mean, and mode, and all skewness, kurtosis, etc. For continuous distribution functions. So we will first begin with the arithmetic mean. In this case, uh, when we find the values of a continuous probability distribution functions and also the probability density functions, so we have to given some questions in the case of mean, median, mode, and kurtosis, and mean deviation. So the formulas are very different for these terms. So first of all, we write here first is arithmetic mean. So in this case, if we want to find the values of arithmetic mean, so first of all, how to find the arithmetic mean? So the formula of arithmetic mean in the continuous distribution is very simple. The limits also given in the question, and suppose that here limits are a and b, and fx is the fx is also given in the question. Fx is a function and is already given in the question, and x is will come in the case of arithmetic mean. And the second question, we can write arithmetic mean is equal to mu1 dash, because this is the first moment of our moments. And suppose that we will find the variance, and in this case of variance of we have to find mu2 dash and mu1 dash, because mu1 dash is also is already found, because mu1 dash is arithmetic mean. Now in case of mu2 dash, mu2 dash is equal to, so in the case of mu2 dash, we have to write here x square in place of x. So we can found mu2 dash easily if we put x square in place of x. And after finding the value for mu2 dash and mu1 dash, we simply put the values of mu2 dash and mu1 dash and calculate. After calculation, we can find the value of mu2. Now the second question is harmonic mean. In case of harmonic mean, if we want to find the harmonic mean, so the formula would be 1 upon h is equal to a to b is our limit, and 1 upon x fx dx. So this is the formula of the harmonic mean. Now the third one is geometric mean. Now suppose that we want to find the values of the geometric mean. So in this case, we can write here log g, because geometric mean is denoted by a log. So log g is equal to a to b, and log x fx dx. So the formula of the geometric mean is log g is equal to a to b log x fx dx. Now the fourth formula of will be, suppose that we want to find the values of different moments. So the common formula of the moments is mu r dash is equal to because mu r dash is the common formula for our movements. We can simply put the values in the place of r. Suppose I want to I want to find the value of mu1. So we can write here 1 in place of r. So we can simply find the value of mu1 dash. So mu r dash is equal to a to b x to the power r and fx dx. So this is the formula of our moment. And now the second formula is about point A. About the point x equal to A. So this is the point. It will mention in the question. So mu r dash and a to b x minus a to the power r fx dx. So this is the formula about the point x equal to a. Now we want to find from the mean. This is from the point A, this is from the point from the mean. So we can write a to b x minus mean to the power r fx dx. So this is the value from the point and this is the value from mean. Now the next term is median. So now the next term is median. Suppose we want to find the value of median. The formula of median will be, so next term is median. In this case, suppose that we have given a function in the question and we have given limits also. Suppose that the limits are 0 to 1. Now we want to find the value of median. So in this case, the median is the term when we divide our values in two parts. So in this case, when we divide our whole terms into two parts, so this would be equal to 1 by 2 and the limits will be 0 to m and function is equal to 1 by 2. So this is the formula of the our. So here given suppose that here is 0 and suppose the limits are a and b, a to b. So in this case we can write a to m and also we can write m to b fx dx. Here you can write also dx. So the formula of the median is a to m and we can also write here. So we have to remember that this would be equal to 1 by 2. The next term is the mean deviation, and in this case, suppose that we want to find the values of mean deviation. So mean deviation mean deviation. Mean deviation is equal to equal to a to b mod x minus mean fx dx. fx dx. So the formula of the mean deviation is equal to x minus mean fx dx. Now the formula of the quartiles. Quartiles means what? Quartiles is a part of, suppose that we have given 0 to 100 and this is the midpoint of our observations and this is called the median. This is called the median. So in this case we divide the whole values in two parts. The midpoint is called the median and a half, so this is the half term and this is the half term. So I want to know the value of this point and this point. So this is the 1/3 part of the our whole observation and this is the 1/4. Sorry, 1/4, because this is the total are 4 parts, 1 2 3 4, and this is the 3/4 and this is the 2/4. 2/4 is equal to 1/2. So 1/2 is equal to median and 1/4 is equal to q1. This is the first quartile and this is the third quartile. So in the case of the first quartile, we will have to write here 0 to q1 and suppose that limits are a to b. So a to q1 and fx dx is equal to 1/4 and in the case of third quartile, we have to write here a to q3 fx dx is equal to 3/4. So 1/4, this is the first quartile and 3/4 is equal to third quartile. So now the next term and the last term is mode. So in the case of mode, the mode is also called the largest frequency of the distribution. Mode is called the largest frequency of the distribution. So mode, so how to find the value when we have to give in the function? Suppose that we have to give in the function fx and the limits is a to b. Okay, now we will have to find the values of now we will have to find the mode. So how to find the mode? So first of all we differentiate with respect to x and this is the first step of our this is the first step of finding the mode. This is f dash is equal to 0. Suppose that here we have to find you can find values of the constant term, so we can put the values is equal to 0 and the second term would be again differentiate with respect to x and if f double differentiate is less than 0, that means this is the maximum value of our frequency. Okay, so in this simple words, first of all, we have to find the first differentiate and the second step is find the second differentiate. If the second differentiable is negative, the value of second derivative is negative, that means is less than 0, we can say that this is the value of our mode. So suppose that we have given the function is 5x. Okay, we have given the function is uh, 5x. Okay, suppose that 5x and the limits are given in this situation is 0 to t. Okay, now the first term is find the value of the f dash x is fx. So this is the value of fx. F dash x is equal to 5. Okay, so f dash x. So this is the differentiate. So we have we not need to the integral signs because in the differentiate we have we need any integral. So this is the value of f dash x. The second term will be term differentiable is equal to 0, and we can say that this is the mode of our function. So 5 is the mode of our function. So this is the whole of the terms that we teach in this video. Thank you so much for being with us, and thank you for watching this video. Thank you so much.